Hello, welcome to my bench. Today we have this here little M267 antique mic mixer. This is a Shure professional microphone mixer, and they are used in a lot of radio stations. I mean, I've seen them everywhere, along with the M67, which I have a video on fixing one of those. I'll try to link it into the up there somewhere, right there. If you want to go see that, that's the older brother of this one. However, we got something else to talk about first. I finally did it. I decided, you know what? You turned, David, me, you turned 70 in February. 5, 6, 70. And it was time for you to quit going to work. After all, you know, you did retire in 2015, took your little trip around the country and saw everything for 4 months, came back, went right back to work again. Well, I think it's time to stop that, and I turned in my resignation after almost 30 years at the radio station and said, this is it for real this time, and I'm going to retire-ish, go home, spend full time working on my bench and doing YouTube videos. And as you can see, I had a sort of a reason for that. And if you look there, right up there, you'll see that I have finally gotten to the point where I have approximately this number of YouTube subscribers. And it pauses. And I promised myself when I got up over 1,000, 1,160, I would start doing a lot more videos. And that's what I'm going to do. I have a whole bunch of things that I've gathered up over the last 4 years that we'll be taking a look at. Some of them work, some of them don't, but all of them are old. That's kind of what I specialize in, is old radio station gear. And through my videos here, I have gained quite a number of people that send me in their stuff to get fixed, because not all radio stations can afford to buy new stuff every time it goes out, especially the little guys and some of the big ones. And I offer a service of fixing that stuff for them through my little company. And that's what I'm going to be doing. This bench is going to get used a lot, and most of the stuff that I fix, you guys will see. So that's where I'm at now, and I hope you'll follow me along. And don't forget to subscribe down there and ring that bell, and make some comments. I like comments. They're fun. So don't forget to subscribe. But now let's get on to this thing. This is just like the standard old M67, except it's a different color, a nicer box, looks a little bit more modern, and it looks like it jumped into the 80s, which it did. On the front here, we've got 4 inputs, mic inputs, and a master input, just like on the M67. We've got a battery switch, because this thing will run, I think it's three 9-volt batteries. We'll look into that. You've also got a switch on the front here for input or oscillator, so you can turn on an oscillator, adjust your meter, and it's all set up so that you know what you're putting down the line, on-off switch. Each one of the channels has a low-cut filter to get rid of some of the bottom end rumble and stuff, make more intelligent voice sounds. And this one also has a limiter. It has a built-in peak limiter, which we'll take a look at on the schematic here in a minute. Also has a headphone output and adjustable. On back, we've got 4 microphone inputs. Imagine that. And these are each individual one is set up so that you got liner mic. So you've got like plus 10. I think it's plus 10 on this. So we'll find out in the schematic. Or minus 50 for microphones on each channel. And you've got a liner mic level output over here for minus 50, like if you want to go mic in, mic out. And it's got, they call it simplex. This is actually 48 volt for phantom microphones. There's only one. There's not one for each channel. Only one, and it puts a 30 some volts, I think, on the mic channels here. Separate or isolated with a 1000 ohm resistor, so that you're not banging the heck out of some poor standard mic if you forget to turn this off. But it supplies enough voltage for the electret mics to work, and condensers. Has a headphone switch here, which a switch here, not for the headphones, which will give you amplified or line out of this port here also. And it has a ground, a real screw ground. It has an input for 30 volts DC and a VU range for +8 or +4 for the front VU. Also over on this side, it has what it says is bus mix. That's so you could stack several of these on top of each other. I don't know what the limit is. I've never even looked. I don't think I've ever actually done that, but you know, you could. So here we've got this is your line out with a XLR, and this is your line out with a set of screw-ons. You know, BNs. They're little connectors back here. These have holes. Yep, they got holes in them, so you can put a piece of wire in here, clamp it down, and it won't come out when this thing falls off the bench or the table remote. Anyway, that's what's on it. And we'll open up the bottom here real quick. And yes, it takes 3 9-volt batteries for 18 volts. Plus it also has the input on the back for 30 volts DC. And a power cord, or not. Somebody decided, well, you know, it'd be easier just to hack it off to get it out. I salvaged this from a dumpster. And this and a bunch of M267s too, and some little TVs, radios, or a television station that was getting rid of a bunch of stuff. I went over to pick up one specific thing, and I saw the dumpster full of garbage, and I said, oh, hey, can I go through that? And they said, sure, go for it. So I did, and here it is. Anyhow, somebody's already taken all the screws out of it. These two, we'll show you in here in a minute. These two are not part of it. But to get these things apart, if I remember correctly, I have not been in, I haven't done anything with this. I have no idea if it works. You have to kind of pry up on the sides, get it going, get it started, and then keep prying to get it past the board and the card so that it comes out. Yep, I was right. See these? I mean, everything's done with these to try to make them quiet in an RF environment. These little copper tabs must be glued down with some sort of a conductive tape, or they hit along the edges here to try to block some RF. You got to remember, a lot of this stuff was used in a radio station where The 1,000, 2,000, 10,000, whatever watt AM transmitter antenna was 10 feet from the back door. So you had to make sure that your stuff was pretty well RF shielded so that it didn't induce any kind of noise and hum into it. So oh, it's cold. So let's see what's in here. Well, this isn't a super duper antique, but it sure isn't new. Everything is through hole. We've got some ICs. What do we got here? 1458. Another 1458. 45. What is this one? MC 4558. There's an LM339 and another 4559. So these are 4559s, 4559s. Bunch of diodes, and these little, very expensive, very accurate, very nice little transformers. Yes, it's transformer coupled. It's the way it should be, says the guy from forever ago in radio. Nobody does transformer coupling anymore. If you go into a modern station with a modern engineer, tell him that you want a transformer couple something, he'll throw you out. Okay, and evidently for the voltage regulator, they're using a tip 30. So, there we have it. And we got a couple of capacitors, 470 microfarads, 35 volts, bunch of little guys down here. These guys, these little silver ones, can sometimes be a problem also. This is an ICC, probably okay. I'll bet you that all of them are okay. Anyhow, you know what? Let's plug this thing in and see if it works. I'm not going to hook up the AC. The AC just goes to here. I'm going to, let's see. If this doesn't work, we can put batteries in it. Ooh, that is a tight fit. We'll find out. All right, let's see. Turn on the power supply. Here, let's bring this camera up so you can kind of see what I'm doing. And turn it up to 30 volts. Close enough. I wonder if it's positive. I don't know. Let's turn the current down. And turn it on. And turn it up. But evidently it's positive. Okay. Hey, it's drawing some current. It's drawing 20 milliamps. Says the battery's fine. Push the battery button. Hey, that's a good sign. Well, that is not what you'd call a damped meter, is it? Okay. Alrighty. And let's see if we got any kind of oscillation. Nope. The oscillator's supposed to be on number 1 here. It does not look like it. Okay, well, interesting. Well, let's plug something into it. Oh, what have I got right off the bat? Here we go. Yep, that's right. Plug that into there. And turn you on. Plug you into line 1. And V's got, whoa, baby. We got really dirty pots. Okay. Take this down to line level. Look at that. Ha-ha! We got level. Very touchy and very dirty pots. I wonder how it sounds. Well, let's see. How can I do that? Well, I have somewhere around here, I have this guy. This is balanced out. So we'll just take this. I'm just feeding this directly from into a little stereo amplifier. So it'll only be one channel, but that's fine. Don't care. Alright, and we'll go line level out and no ground. Okay. Turn you on. Home. Home. Alright. That's what ground's good for. I don't know, you probably can't hear that, but it's humming. Alright, now it's not humming. So, turn it down. Ha 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 ha! We have audio. Alright. There we go, look. Does peak light work? Peak light works too. Turn the limiter in. That doesn't appear to be doing much. Very good. Wonder if all the channels work. I really had no idea whether this thing was going to work or not. And we got to try the mic too. Let's see. Line level. No. Bad. Dirty pot. Dirty. Okay. So that one works. Quit being so noisy. This one? Yeah, that one works. And this one works too. Wow, they all work. Well, that's cool. Let's find out if the mic preamps work on it. Okay, got a 50 dB transformer coupled. It's line in to mic level out. So I can test things that have mic level inputs. Ooh, the mic works. All right. Well, since we know all this works, how about the oscillator? All right, so if I put this about mid-range, and this about mid-range, I should be able to get more or less zero level out of it. And I do. So, let's find out how close we are. It should be about, ooh, way too high. Of course, it's 3. This is 0.6, that's 600 ohms. So about 7 out of this thing, I know what it does. That's about right for what we've got going into it. And let's try it direct. And it's the same. Holy smoke. So basically all this thing needs is some cleaning up. And well, one other thing we need to do here. Let us turn this down because it's annoying. Let us take the output of this. You know, the output of this. Which is, ow, why do you get all tangled up? Okay, so I got this guy, which has a 600 ohm impedance matching inside of it. And those do not look good, those connectors, but we'll find out. We'll take you off of here. Don't have to. You can leave that on there if you want to. And this is going to go into the the distortion meter. Amplified output. And I want line out. Put it at about 0 dB. Set this guy up for level. And we'll not great. Yeah, I'm missing the ground here. We're looking at about 1%. Wow, that's like horrible. Let's turn the amplifier off here, or this, and just make it. That's not. There's a straight line out. It is straight line out. I would think this would be a little bit better than that. But I'm looking at about 1.5% distortion. These are supposed to be good for about 0.35. So, what does that tell us? Well, I don't know. Let's take a look and see if we can see this on the scope here. There's a picture of the scope. And wow. Yeah. See that stuff in there? Right there. Right there. See that? That's where your distortion is coming from. And I can guarantee you that's power supply. That is almost impossible to see. But if I cut everybody down, crank it up just ever so slightly, you can see it in there. So what we need to do is we need to change some caps. And we'll do that. I'm going to start with this one, these two. I'll check these guys over here. You know, all of them. And we'll see what happens when we come back. You've seen people change caps before. You don't need to watch that. Anyhow. You know, actually it occurred to me when I was unplugging it here. This thing was on a well-filtered DC power supply, so it's not the power supply itself. It's going to be one of the caps here. So let's take a look at the schematic. Pull it up here. Wow, big schematic. Okay, let's get rid of this one and pull up this one. Okay, let me make that a little bigger. There. So what do we got? Well, your main amplifiers, I don't think it's them because I was going in direct, so it's not going to be mic preamps. So it's going to be probably in one of these sections here, because we've got, let's see, this part here is the oscillator. This part here is going to be the mic preamp, I think. Let's see. Line. Let's pull it up a little bit. How does this go into here? So 2 is in coil through the transformer. This is your input. That's your oscillator switch. This is your mic line. So what does it do? So it's in mic. So it just all basically bypasses that 33K resistor. Alright, so it might be these amplifiers here, of which there's 4 in a package, and that would be 2018 or 201, which is 201, which is this guy right here, which is a RCA 4156 dB. So these are identical circuits. These 4. Let's try this guy here. And what do we got for capacitors? 39 picofarad. We got this one, C201, which is 22 at 6.3. C201, which is right there. Just to make this easier for right now, rather than taking this board out, because as you might be able to tell, these boards are like kind of interconnected front and back. So we're going to cheat. You didn't see me do that. Let's get rid of the manual. Alright, I just cut one end of C201 here, which is a 22 microfarad at 6.3 volts, I believe. We're going to hook it up to the little magic wonder box here. Cross pins 1 and 3. And turn it on. See what it says. It says the voltage is okay. It says it's testing a cap. And it's taking a long time. Capacitor, come on. It's a capacitor, 29 microfarads at 2.1 ohms. Well, that's not terrible. Really? Shouldn't be enough to do that kind of stuff. Remember I was saying that these little silver guys are sometimes a problem too. So we'll cut him loose. And we'll give him a test. Yes, this is the cheating way to do it. 5,617 nanofarads, so 4.7. It's supposed to be 4.7. If it is, it's way off. At 3.3 ohms. Not great. So well, I don't think that's enough to cause this. That's pretty okay. So let's see if we go a little farther. What else is in here? Bunch of resistors, not too much. I mean, yeah, 4.7 at 35 for C101. C101? C101. What is this one I just cut? That would be C209. that resistor, the capacitor, the second one I cut was right here. The C209, and that has this one, which is another one, which is C101, which is over where? Wow, I don't see any ones in this thing at all. Might be. Huh. But is that where all of them combine to join each other? That's the mix bus. So no. Trying to find out where all of the outputs of these amplifiers go to join each other. There's your low cut. There's your output. There's this. Ah, okay. So they all join right here, I believe, because there's that one. There's that one. So there's 1, 2, 3, and 4 right there. Okay, so they all join here at W305. So tell you what, hold on just a minute, and I shall be right back. Okay, well, went and got some coffee, heated it up. We got a little problem. We need to figure it out. It's not that this thing is working badly, I don't think. Let's trace this thing through. I can't use my on-screen scope, unfortunately, because it doesn't have an AC input. It only has DC, and since I got 15 volts everywhere here, it just goes slapping off the screen. So we're going to have to watch this scope over here. And I don't know if I can get this in a better position to kind of... Is that better? Alright, I guess. Alright, so we're going to go and trace this thing down and see what we've got. Let's go to... Let's pull the manual up here. Alright, let's go over to... why not? Start at the beginning. We'll go to the input of this U201B, which would be pin 5. And right there is 5. You can see it's not much because, well, let's see, what am I on? I'm on 0.2. There it is. It's pretty low level. That's the input. So let's go to the output. There's the output. And look at that. Look what we got. That is garbage. That's on pin 7 of this chip, which is right here. So let's take it across to... what does this do? Oh, okay. So my low cut is out. It's going straight across to 304, right to the input of this C209, which is this one we did over here. Let's see if we can shrink down this or this meter, whatever you call it, manual, just a little bit here. Whoops, wrong one. Alright, try to shrink this down so you might be able to see what I'm doing. Okay. So we tested over here on pin 7, and that's the output of right here, and this whoops, right here on this this IC. Why is that not showing up now? Yeah, right there. Okay, and we'll go over here to C209, which is right here, and we still got it periodically. It's still there. See the fuzziness and noise? Okay. The other side is C209, same thing. That's on pin 2 of this Q203. We go to pin 8. Pin 8? No, pin 1. Ha! 8's the power supply. Go to pin 1, which is after this amplifier. We got lots more, but we still got that noise. And then that goes through to here, which is this is your master output. So this is your main input, and we go to pin 7, your master output. Shrink it down a little more. Well, that sort of, let's see, we still got it. See it right there? See that fuzziness? I don't know if you can see that or not. Can I even, yeah, right there, that fuzziness. And that is what's giving us our problem with the Distortion Analyzer. So, okay, well, it comes out of there, goes through this Q202, and I'll bet you that'll be even worser. Yeah, right there it is. Input, output of Q202. It's basically a switch from what? Limiter threshold. So that would, yeah. Okay. So that's the little limiter circuit on IC204, so we don't have to worry about that. So it comes down here, goes over, comes down, goes on to Q201, which is 201, which is right here. It's not as much, but you can still see it, and there's the output of Q201. All right, so what is happening here? Our input, bring this down, bring this up. Our input is what I would expect it to be. I mean, I've only got 2 volts going into it. Our output of this chip is pretty big, and it's got some noise on it. Wait a minute, what's that? Oh, okay, you can call me silly now if you want to. It's all right. Let's see if we can get this up in position so I can show it to you. See that noise on there? Watch happens. Do you see what I'm doing? I'm putting my hand on the box itself. I think I have an idea. Let's see if my idea is right. Let's get rid of the manual. And we can get rid of that for right now. I'm going to take this guy, turn you off for now. I'm going to take this guy, and I'm going to put him back on where he goes. We're going to turn it on, and we're going to take a look at our output, and it is it's clean. let's see if we can get a picture of this here. Ooh, good production. There. Look at that. The amplifiers in this thing are running so hard that anything will mess them up, including the top not being on it. So let's take the top off again, which is easier said than done. Screwdriver. Turn it off so I don't short anything out. Okay. Okay. That's off. That's on. Oh my goodness. Look at this. Look, 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 look. That's the noise we're getting just from the top being off of the device. I noticed when I put my hand on it, it went away. Look at that. Look at that. That's perfect. All right, so let's put the top back on it and let's plug it into the. I mean, if I was going to sell this thing or use it, I don't know what I'd use it for. I mean, shoot, you can get this whole thing now in one little chip that's a whole lot better. Better specs, better everything. I'll tell you, these things are real. Whoever designed this case, I'll tell you. And this is actually the way it works. It really is. Ow! Ow, that hurt. Yep. Hey, I'm doing it right. It drew blood. Ouchie. All right. It's back. It's on. It's running. And show you again here. It is. Look at that. Clean. Now let's take it over and plug it into the Distortion Analyzer and see what we got. Alright, distortion plus, where am I at? Back you down to 0. Put you over here. Onto distortion. Okay, here we go. Show you what I'm doing. One of the things I do, because I've been in radio so long, is every piece of equipment that's audio that goes out of here, I do distortion analysis on, just because that's what everybody wants. All right, so I put this thing up here. Put this on set level. Going to set my level over here and turn this knob until that's about right on the 1. Put it over on distortion. Let's turn this up so you can see the whole thing. Find my frequency, which I'm doing with this knob over here. Find my frequency as close as I can get it. Okay. Ow. That thing was biting into my thumb. All right. And then this knob here. This is the coarse balance adjustment. All right. Now we start walking this down. Do your balance adjustment. Do the best you can on your frequency, which is about there. Walk it. And then do your balance adjustment again. The new guys don't require this step, all these steps. They'll balance themselves and they'll actually find the frequency for you. All right, so there we are. We are on 0.3% right there. It costs 600 ohms, which it is. So it's 0.3% on that scale right there. So that's 0.3, 0.2, 0.12. So we've got 0.12 total harmonic distortion, 0.12 and a half. That beats all specs right there. So that's the difference the top makes. Oh boy, I'll tell you. Well, you know, live and learn, I guess. Anyhow, yeah, but if I was going to sell this thing or use it or whatever, I would go through and recap it, of course, and put a new power cord on it. And, you know, maybe if I would use it, I probably should use it now because it drew blood. Sheesh. Anyway, yeah, I'd go through and clean it up, but I really don't have a need for it. It was just in the trash can, and it just hurt my feelings so bad to see it there that I just had to dig it out. We got a bunch of stuff like that out of that trash can, so anyhow, there's a look at an M267 and chasing your tail around in circles because you didn't put the lid on it. Ha! I love it. Okay, hey, whatever. That's how they work. Hey guys, thanks for watching, and give it a thumbs up if you like it, and don't forget to subscribe and ring that bell, because we, you know, like I said, I'm doing this full time now, and we need all the subscribers that we can get. Till next time.